In this video, we're going to take a look at inverse functions. So inverse functions, there's a big idea that you need to keep in mind when talking about inverse functions. We need to switch x and y. That is a big idea with inverse functions. So always remember switch x and y and you'll be headed in the right direction with your thoughts. We can also write that they reflect over the line y equals x. So that's what you want to think about when you think of a graph that represents two inverse functions. They will reflect over the line y equals x. Okay, so determine if the inverse is a function. You can type it in Desmos and check the vertical line test. So we'll look at some examples. It says find the inverse, identify the domain and range, and determine if the inverse is a function or not. All right, so let's just look at a few examples of finding the inverse. So if f of x is this list of points, to find the inverse, we label it with a little -1 to indicate that this is the inverse of f of x. And all we need to do is switch the x and the y with each point. So it was 1, 5, I'm going to make it 5, 1. It was 2, 6, so I'm going to make it 6, 2, 7, 3, and 8, 4. So that's all we have to do for a list of points. If they ask you for the domain, you can just simply list out the x values of that list of points. So it will be 5, 6, 7, and 8. And for the range, we could list out the y values. So we have 1, 2, 3, and 4. And to determine if it's a function, you want to see, is there one x for each y value? So we do have one x paired with each y value. So then we would say, yes, this is a function. For number 2, it's a table of values. So in a very similar way, we're just going to switch input, which is our x, with our output, which is our y. And so we're going to have a new x and a new y for our inverse table of values. So I'm just going to write inverse out here. And let's put 0, -2. In the next row, we have 1 and then -1. We have 2 and then 0, 3 and 1, and 4 and 2. So notice for each x, you're checking to see if you have a unique y value. So 0 goes with -2, but no other x value would go with -2. 1 goes with -1, 2 goes with 0, 3 goes with 1, and 4 goes with 2. So each x has a unique y, so we would say, yes, this is a function. And if we listed out our domain, we would say the domain, I'm just going to write it at the top, would be the x values. So 0, 1, 2, 3, 4. And the range is the set of y values. So -2, -1, 0, 1, and 2. All right. So in this next table of values, let's do a very similar thing. So let's just write x and y. We could put a little -1 to indicate this is the inverse, or you could just write the word inverse above the table of values. And let's just switch. So 1 and 1 looks the same, but we're going to have 4 for x and 2 for y in the next row, 9 and 3, and 16 and 4. So for each x, notice you have a different y value. They don't repeat. So we would say, yes, this is a function. For my domain, I would list out the x values. So 1, 4, 9, and 16. And for the range, I would list the y values. So 1, 2, 3, and 4. All right. So let's look at inverse with a graph. So for a graph, we need to pick out some points that are easy to find. So I would say this point looks nice and simple. That would just be 0, 1. And this one looks nice and simple, which would be 1, 3. And let's say that one right there, -2, -3. So I'm going to rewrite those over here on the side. I have that my x and my y values are 1, 3, 0, 1, and -2, -3. They don't have to be in any particular order. All I need to do now is switch them for my inverse and then graph those points. So I'm just going to make another table and I'm going to switch them. So I'm going to say 3, 1, 1, 0, and -3, -2 are going to be on my inverse graph. So then I plot those points. So I'm going to move these points out of the way just to make my graph look a little bit cleaner for a minute. So let's plot our new points. So 3, 1 would be right there. 3 to the right, 1 up. 1, 0 is just 1 to the right. And then -3, -2 is left 3, down 2. And then I can connect my points and make a nice straight line. All right. So what you should notice with a graph is that they reflect over the line y equals x. So I'm going to grab a different color and I'm going to plot the line y equals x, which has a y-intercept at 0 and it has a slope of 1. So it's not really part of our inverses, but it just shows you that these two lines and any graph that's representing inverse functions should look like it reflects over that line. And it does. Okay, so then in this next little set of examples, we need to look at finding the inverse if you're given an equation. So two main things we need to do. And let's highlight those. So we're going to simply switch x and y and then solve for y. There's just those two steps. So in example number 5, I'm literally going to switch x and y, but leave everything else like it looks. Nothing else moves. It's like x and y just traded places. So number 1, switch your x and y. Step 2 is to solve for y. All right, so let's solve. All right, so let's add the 1 first. So we get x plus 1 equals 3y. And then we can divide by 3. So we get x plus 1 divided by 3 equals y. But we don't want to say just equals y because that's what the original equation said, and we're not looking at the original equation. We have now found the inverse of it. So put a little -1 on the y just to indicate that now you have the inverse of y. And sometimes they ask, is this a function? So let's grab Desmos and let's check and see if it is a function. So all we need to do is check the vertical line test. That's what it says at the top of your notes. Let's look at that. So let's type in x plus 1 all together in parentheses divided by 3. So what you're checking for is, could you draw a vertical line through your graph and only touch it once? And since this is just a line that's slanted, I definitely could draw a vertical line through that graph and only touch it one time. So we would say, yes, this is a function. My inverse is a function. All right, let's look at number 6. So first things first, let's switch x and y. So let's put x equals y plus 3 divided by 5. Then we're going to solve for y. So let's first get rid of the 5. So multiply both sides by 5. So we get 5x equals y plus 3. We're still solving for y, so let's subtract 3. And we get 5x minus 3 equals y. But then put a -1 because you've now found the inverse of y. You don't have y equals, you now have the inverse of it. And then if you want to check and see if that is a function, you can just type it in and think of your vertical line test. Meaning, can I draw a vertical line through that graph, and no matter where I draw a vertical line, can I only touch it one time? And the answer again would be yes. So that is a function. All right, for number 7, let's do the same thing. It's always the same steps. Switch x and y and solve for y. No matter what the equation looks like, that is what we're doing. So I switched x and y. Notice everything else stays the same. Now let's solve for y. So let's subtract 4. So I get x minus 4 equals y squared. Then let's take the square root to get rid of the square. And when you take the square root, you have to put plus or minus the square root of x minus 4 equals y. And then put your little -1 to indicate the inverse. Now to see if this one is a function, we actually have to type in both. We have to type in positive square root of x minus 4 and a negative square root of x minus 4 to check, let's write that out, to check if it's a function, because that's all we're checking for in case they ask that question. If they don't ask, you don't have to worry about it. But if they do ask you that question, you need to know how to answer that question. So let's type positive square root of x minus 4 and then negative square root of x minus 4. And notice, let me turn those into the same color. It looks like a sideways facing parabola. So if I were to draw a vertical line through that graph, I could touch it more than once. I could touch it twice. So this is not a function. So we'd say no, not a function. Okay, let's look at the last example. So number 8, switch x and y. Leave everything else where it is. So x equals y cubed minus 2. Then we're going to solve for y. So let's add 2 to both sides. So we get x plus 2 equals y cubed. And then you want to get rid of the cube on the y. So let's take the cube root of both sides. And we get the cube root of x plus 2 equals y. And then put a little -1 to indicate the inverse. You have found the inverse. So to type the cube root, you have to go to Functions, Miscellaneous, and then find in that middle column, there's a little n, like nth root button. And you can put the cube root into Desmos using that button. And then type x plus 2. And notice this one looks a little different. It looks kind of like that. But if I draw a vertical line through this graph, no matter where I draw my vertical line, I'm still only touching this curve one time. So we would say, yes, this graph is a function. So my inverse is a function. And you can check to see if any graph ever is a function using that concept. All right, so that's it for our notes on inverse functions.